Greetings, fellow grade 11s. It's Mr. Shajayo here, and welcome to Back to Basics. Look, what I want us to look at today, I want us to look at our what? I want us to look at these four different examples of our general solution, right? Now, I want us to work with these particular examples and see in terms of how do we go about when we, when we do our, our general solution. Let's start. The first one, you are given that you're having what? The first question is you're having sine of theta, which is equals to your 3 cos of theta, right? Now, I am saying to you now, whenever you think of, or whenever you see your sine this side and your cos this side, you must automatically think of your tan of theta, because you know that if you can have sine of theta somewhere and your cos of theta somewhere, you can definitely have the tan of theta. So now what does this mean? Basically, we are saying now here, what is it that you're going to have? You are going to come back here and say, now look, if I can come to both of these sides and divide by cos of theta on this side and divide by cos of theta the side, what is it that I'm going to have, right? So which means now I'm going to have what? I'm going to have your tan of theta. Remember, sine over cos is tan, which is going to be cos what? Now here you are going to have only what? The cos and the cos are going to cancel each other, which means you're going to be left with 3. Right now, and as soon as you do that, now what is it that you are going to be left with? Now you are left with 3. So remember, we are solving for what? We are solving for theta, which means now our theta is going to be given by what? It's going to be given by shift tan of what? Shift tan of 3. Now remember that your tan graph is going to what? It's having a period of what? It's having a complete period of 360, so of 180 rather. So this is going to be 180 degrees plus k, where k is your what? Where k is your element of real numbers, right? So then now from there, what is going to be this? Now your value of your theta that you're going to find, your theta, you are going to find this theta as what? You're going to find your theta as your 71.6 degrees. Once again, now that's going to be the first one, 71 point that. Now, where are you also going to find your theta, right? Now, the next thing where you are going to find your theta, now you are going to say, look, remember, you are going to say now, if you can check where is also our tan of theta going to be positive, right? Where is going to be our tan of theta also going to be positive? So now if you can check, our theta is firstly positive in the first quadrant, and in which quadrant? And in our third quadrant. Remember this, it's all here, it's sine, here it's tan, and here it's cos, right? So which means here it's 180 degrees. So which means here you can say now another value of your theta, where your theta is positive, is going to where you are having 180 degrees plus your what? Plus your theta, which means in this case it's going to 180 degrees plus what? Plus 71.6 degrees. Altogether, then therefore the other value of your theta is going to be given by what? It's going to be given by 251. I think this is going to be 251.6. 251.6 degrees altogether. So basically now this is going to be the two solutions of your theta that you're going to have, right? Yes. So now let's look, let's move swiftly to now our second one. Let's just make up our space here. So you are given that you're having 3 cos squared beta. This is going to be plus 5. This is sine of beta. Then this is equals to 1. Now, the first thing that you need to do, I want us to have an understanding of this. Now, it is almost going to be impossible for you to work with what? For you to work with your cos and your sine altogether, because these are unlike terms, right? But you know that your cos squared of beta can be changed in terms of sine. How can you do that? Let's start here. You know that you have the identity that which state that your sine squared of what? Of theta plus what? Plus your cos squared of what? Of theta is equals to 1. And now look, if you want to make your cos squared theta your subject of the formula, can you see that this is going to be cos squared theta is equals to 1 subtract what? 1 subtract sine squared theta altogether, which means now you can come back to the same equation and cos squared, where there is cos squared beta, express it in terms of 1 subtract sine squared beta, right? So which means this is going to be same as 3 into bracket. This you are going to have what? You are going to have 1 subtract sine squared your theta plus 5 let's see, this is going to be plus 5. Again, this is still sine of your beta is minus 1 is equal to your 0, right? So basically, this is what I've done here. Now, secondly, how are you going to do this? Now, you can distribute the 3 everywhere now, which means this is going to be same as 3. Subtract your what? Subtract your 3 sine squared of what? Of beta. Remember, here it's your beta, it's not your theta rather, right? Because you're given here in terms of beta. So this is going to be plus your 5 sine of what? Sine of beta. Subtract 1 is equals to 0. Then now, this is same as what? This is same as negative 3 sine squared beta. Then now this is going to be plus 5 sine of what? Sine of beta. When you say 3 subtract 1, this is same as what? Plus 2 is equals to your 0. Now, let's say we change our first coefficient of our sine squared. This is same as what? This is still the same as sine squared beta. Subtract what? Subtract 5. This is sine of what? This is sine of beta. Subtract your 2 is equal to 0. Basically, here I've multiplied with the negative. How to get? Now, after that, what is it that you're going to do? Now, I want you to have an understanding of this, right? Now, ordinarily, this is just like your quadratic equation, because if I can just replace the sign of beta with x, can you see that this is going to be 3x squared subtract 5x subtract 2 is equals to 0. I want to get. And now, if let's say you are having this, you'd know that to factorize this, you would just go open 2 brackets and say this is going to be 3x. This is x, and you'd say now here for you to have your 5, this was going to be your 2, and here it was going to be your 1. Out again, this was going to be your negative, and this was going to be your positive. Out again. Now, let's say this was your quadratic equation, right? Out again. So the same is true, right? You can use the same factors, but now replace the x with the sign, because here you are given the sign. Out again. So which means now, when you are replacing that, this is still the same as what? You can open your 2 brackets here, right? Open your 2 brackets. This is still the same as what? Sine of beta. We are factorizing here. And what? Here you are having sine of beta. This side you're having 3 sine of beta, and then beta this side. Now, your factors of 2 is going to what? It's going to be 2 here. Here it's going to be 1. Remember, we are factorizing, and we said here this is supposed to be negative and this is supposed to be positive. Out again. And now, from here, what is it that you are going to do? Then you'd know that this 3, it's going to be 3 sine of beta plus 1 is equals to your 0, right? Or this is same as what? This is same as sine of beta subtract 2 is equals to your 0. Out again. And then now from here, you can find the solution for both of your sine of beta. Out again. Now, let's say we firstly start with this one. Your sine of beta, here it's going to be what? This is going to be sine of beta, which is equals to 2. And now, anything like this is going to give you what? This is going to give you no solution. Out again. Now, this one here, you are going to have no solution, because when you say beta is equals to shift sine of 2, you are going to have what? You are going to have no solution, right? This side. But now, if you can come on this side, let's see in terms of what is it that you're going to have. Now, in here, you are going to have what? You are going to have your sine of beta, which is equals to what? Which is equals to, I'm just continuing this one here, right? And now this is going to be a sine of beta, which is equal to negative 1 over your 3. Together. And now what is going to be this? Your beta rather is going to be given by what? This is going to be same as shift sine of negative 1 over 3. Then this is going to be plus 360k, where k is your element of your numbers. Remember, when you're doing your general solution, this must always be included, right? And then now from here, what is it that you're going to have? Then your value of your beta firstly here is going to be same as what? The solution that you're going to find for this one is going to be same as the negative 19. Once again, now this is going to be your negative 19.5 degrees, right? Now, the second thing that you're going to say, you are going to say here now, where is also going to be your sign positive? Your sign is also positive in your second quadrant. Remember that if this is your Cartesian plane, this is going to be 90 degrees, this is going to be 180 degrees, and your sign is positive in this quadrant. So you can still use what? You can say now, this your beta can still going to have a value where you're having what? 180 degrees subtract what? This is going to be 180 degrees. Subtract the angle that we got, which is going to be what? This is going to be 19 point what? 19.5 degrees altogether. Then now plus, obviously, this is going to be 360k, where k is the element of real numbers. Then now, can you see that the another value for your p, where you're going to have your value is going to what? It's going to be where you're having 199.50 degrees or 0.5 degrees altogether. Plus, obviously, this is going to be plus 360k altogether. This is going to be plus 360k, where k is your element of real numbers. Basically, now these are going to be the two solutions for this particular problem altogether. Now, hopefully this makes sense. Let's just move swiftly along to our number 3 so that we, we save our time, right? Let's just move swiftly along to our number 3. Now, let's just make up our space here, right? Now we are in number 3. Let's just see in terms of what is it that you can do in number 3, right? Now, in number 3, you are given what? Now, in this one, you are given this. You are given that you have your what? You are having your sine. This is same as what? This is your number 3. You are having your this is same as your 3 sine. This is same as 3 sine squared theta, plus this is same as sine of what? And this is going to be rather this in terms of instead of this being your theta, basically this is supposed to be your x. Let's just rectify that, right? And now this is 3 sine x, and then here instead of it being our theta here, it's going to be x. You cannot have your theta and your x, right? So basically here it's your x altogether. So which means we are saying here you are having 3 sine squared x plus this is going to be what? Plus sine of x. This is going to be cos of what? Cos of x is equals to your 2. That's okay. Yes. Now, what is it that you are going to have in here? Right? Now, let's see. Now, the easier thing that we can, probably have here is to start here and understand. Look, this one is still going to be the same as what? This is same as 3 sine of what? Sine squared x plus sine of what? Sine of x multiplied by cos x is equals to your 2. But now I want you to take note of this. Now, here, can you see that here you are going to have sine and cos, which means this is going to be almost impossible for you to work with, right? Okay. But now, look, your 2, isn't it that your 2 is same as 2 multiplied by 1? All right, again. And from our identities, we know that your sine squared of x plus your cos squared of x is equals to 1, right? So which means now, what is it that we can do here? We can come here and say, look, this I can still just write this sine squared x plus cos squared x, right? This, because this is still the same as 1. Basically, this is still the same as my 2, right? Then I take this one this side now. Can you see that this is going to be what now? This is going to be same as, let me just write this here now. So this is going to be now same as 3 sine of what? Sine squared x. This is 3 sine squared x plus your sine of x and your cos of x. Subtract. When you distribute the 2 outside, can you see that this is still the same as what? Minus 2 sine. This is sine squared x. Then when you take the cos, this side is also going to be minus 2 cos squared x is equals to 0. Out again. And now, can you see that what is it that you are having here? Now, is there anything that we can work with here? Yes. Now, we can collect our like terms. Do we have anything that is consist of like terms? Yes. Look, this is 3 sine squared x. This is minus 2 sine squared x. And 3 subtract 2 gives you what? This gives you sine squared x, right? So which means basically here, this is still the same as sine squared x. Plus what? This is plus your sine of x, cos of x, minus what? Minus this is same as your 2 cos squared x, which is equals to your 0. Altogether. So basically now that's that. Now I want to take you back to your this other thing. Now let's say this is x squared plus and this is same as xy. Let's say we represent your sine as x and your cos as y. Subtract this is 2 what? This is 2y squared. Now is there anything that you can do to factorize this? Yes. This is almost going to be the same as what? Look, if you can check this, this is going to be your x and x, right? This is going to be you what? Now what else are you going to have here? Now, let's see, for you to have this, you can have this as your 2y, right? This is can be your 2y here, and here you can have your y altogether. Then now, what is it that you're going to have? The part that is having your 2y, it's going to what? This is going to be positive, and this is going to be negative. Sorry, right? So now, which means yes, these things can be factorized like this altogether, because when you take them back, let's say you take them back, x multiplied by x, can you see it gives you x squared? X multiplied by y, it gives you what? It gives you plus xy. When you say 2y multiplied by x, it's going to give you what? This is basically going to what this one and this one, it's supposed to give you negative 2xy, right? This is negative xy. Yes, this is negative xy. This is going to plus 2xy. And then the last one is going to give you negative 2y squared. Can you see that this one is still going to take you back to this one, right? So which means now, if that's what we have, now I am saying to you now, you can still factorize this, right? I wanted you to see that you can actually be in a position to factorize this. Now, when you want to factorize this, how are you going to do it? This is going to be same as what now? Can you see that this is going to be same as your sine of x, right? And minus what? This is sine x minus 2. What? This is minus 2 cos what? Cos x. The other one is going to what? Sine x. And then the other one is going to what? Remember, this is minus, so this is going to be now this must be your plus. This is supposed to be what? And this is supposed to be your minus. Yes, this is supposed to be your minus cos of x, which is going to be cos to 0. Yes. Now this is how you can factorize this too. And now from here, you can solve this, right? This is same as what? This is same as your sine of x plus cos x. Plus cos x is equal to your 0, or your sine x minus cos x is equal to what? Is equal to 0. And remember here, what is it that I want you to remember here? You are having your 2. So let's write this as our 2. Now, and when you are solving this, now when you take this one this side, can you see that this is sine x is equals to your what? Your negative 2 cos what? Negative 2 cos x. And now from here, what else now can you have? What else can you have now? Look, as soon as you have your sine and your cos this side, one thing that needs to come into your mind is your what? It is your tan. So you can just literally divide by cos of x this side, and then you divide by what? Cos of x this side. Now, can you see that here you are going to have these canceling each other, but here you are going to have what? You are going to have your sine of, you are going to have your tan. This is going to be your tan of 2, right? Let's just make our space here. This side is going to be what? This side is going to be your tan of, this is going to be your tan of x, which is equal to your negative 2. Altogether. And now, what else are you going to have? This x now is going to be same as what? Your x on this side is going to be same as shift tan of negative 2, or which is going to be what? Plus 180k, where k is your element of real numbers. Then the x that you're going to find here, it's going to be same as what? The x that you're going to find here, it's going to what? You're going to have x, which is equal to your negative 63 degrees. This is negative 63 degrees, right? Negative 63 degrees plus what? Plus 180k, where k is your element of z's, right? Now, similarly on the side, you are going to do the same thing. You're going to take this cos the side. Can you see that this is actually going to be same as what? When you take this cos the side, it's same as sine of x is equals to cos x. Then when you divide by cos on both sides, can you see this side is going to what? It's going to be same as tan. Actually, x is equals to 1, because when you divide by cos the side, you're going to have 1. So which means now your x here, your x is going to be equals to shift tan of what? Shift tan of your 1 plus 180k, where k is your element of z's, right? Then your x is going to be same as what? As your 45 degrees. Okay, I know this looks like it's a lot, but basically this is how we are going to do these particular questions. Okay, hopefully this now makes sense to you. Let's just run swiftly along to our number 4, and then we are done with these questions, right? Hopefully you are listening, and hopefully you are getting it in terms of how do we go about solving these particular questions, right? Let's just go straight to our last question, right? Now, this last question, I've just erased it by mistake. I'll just rectify that one just now, just now, right? And now, Sorry. Then now, what is it that you're going to have here? Now, from here, what you are having, basically, this was cos of what? Cos of 2x. Yes. So this is just cos of what? Of 2x. Cos of 2x is equals to what? Is equals to your sine of what? Your sine of x. This is x plus 10 degrees, right? Now, I want you to work with this. I know someone here is wondering in terms of, I see my cos this side, I see my sine this side. Why can't I just, change that to sine or to tan rather? But now this one, can you see that your brackets are a little bit different? So it's almost impossible to do that, right? But between your cos and your sine, you can change in one of them and make it to be what? Either your sine or the other one to be your cos. How can you do that? Let's say, for an example, if you can say here, now, can you see that, isn't it that your cos of 2x, now your sine of this, look, your sine of, let's say, when you say your sine of 90 degrees, or rather, let's say your cos, let's just do this, your cos of what? Let's say we're having your cos x. Let's say we say your cos of 90 degrees subtract what? Subtract theta. Can you see that this is equals to what? This is equals to your sine of x. Now, which means now when there is sine of my x, I can represent that in terms of 90, which means I can still take this one back this way, right? So which means now, for an example, I can just say when there is sine, I can write this sine as cos of what? And then open my brackets here. This is same as what? This is same as 90 degrees, subtract, then let me subtract everything that is have here, x plus 10 degrees altogether. Then that's going to be that. Are we fine? Then now that's going to be that. And then now after that, what else now are you going to have? And then now from here, what you are going to have, this is going to be like that. Now you can change this, right? And now, after this one is like this, what is it that you're going to have? Now, this is same as what? This is going to be definitely the same as what? Your cos of what? Of 2x is equals to, when you say 90 subtract 10, this is basically going to be same as what? Your cos of what? This is same as what? Your cos of x. Or rather, this is going to be same as your what? Your cos of your x subtract 80 degrees. Or rather, your 80 degrees subtract your what? Subtract your x. Remember, the negative here is going to affect everything here, right? Because negative x here and negative 10 here. Out again. And now, how are you then going to do this? Now, you can you can substitute now from here. You can just divide by cos on this side. Out again. And when you're doing that, what is it that you're going to have here? Can you see that? Now, when you divide it by cos both sides, this is same as 2x is equals to your what? Your 80 degrees. Subtract your what? Subtract your x. Yes. And now from here, what is it that you can do? You can come and take your what? Your x this side, right? Now you can take your x this side, which means this is same as your what? Your 2x plus x is equals to what? Is equals to 80 degrees. This means your 3x here is equals to what? Is going to be equals to your 80 degrees, right? So now this is your 3x is equal to your 80 degrees. This now is going to be plus what? Plus 360k, where k is your element of what? Of z's. Now from here, you're going to divide by 3 both sides. Divide by 3 both sides. Can you see that the value of your x that you're going to have? It's going to be same as 26, but what? 26.7 degrees. Altogether. Yes. So basically now that is going to be that. And now, because you are having your cos, can you see that your cos is positive in which quadrant? Is positive in your what? In your first quadrant and what? And your fourth quadrant. Isn't it so? So which means now you can still say that this, your what? Now you can still represent this as term of what? You can say again, now you can take your 2x here. You can say, look, remember this was the expression. You can say, look, my 2x starting just from here, you can say, look, starting from here, let me just point out from here, represent the other degree and say my 2x is still going to be equals to what? I can say this is same now equals to negative 80 degrees. Now, the negative 80 degrees represent your what? Your quadrant 4. This is negative 80. Now, obviously, when you multiply by negative, this one is going to be positive now. Positive x, isn't it so? Positive x, then this is same as what? When you take this one, this side is still going to be the same as what? Your x is going to be same as your negative, negative what? Negative 80 degrees, plus what? Plus 360k, where k is your element of z's, which means now, your what? Your x here is going to be given by what? Your x is going to be given by negative 80 degrees. Okay. So basically, that's what you are going to have as far as this question is concerned. Hopefully, this makes sense to you. And thank you very much.